You know, if you can simplify fractions, you can multiply and divide them quite easily, because all it is doing two problems in one. Truly, the rule for multiplying fractions, a fraction a over b times a fraction c over d, is just multiply the tops and multiply the bottoms. That's all you really need to know, except to simplify the result. For example, a third times 2/7 is 1 times 2 over 3 times 7, or 2 21sts. It's easy, isn't it? Now, another type of problem that involves multiplication is exponentiation. It smells a lot like multiplication because it really is. 2/3 to the third power. You know what? Remember what exponentiation means? 2/3 to the third power means 2/3 times 2/3 times 2/3 3 times. But this is just multiplying fractions. I multiply the tops and I multiply the bottoms. And that's the answer. How about this one? -1/2 to the 4th power. Now how many am I going to write? -1/2 times -1/2 times -1/2 times -1/2. Now remember, an even number of negatives gives me a positive answer. 1 times 1 times 1 times 1 is 1, and an even number of negatives is going to really not that hard. Well, division is very, very similar, except it has one little twist to it. The rule for dividing fractions is to multiply by the reciprocal, the flipping, if you would, of the second fraction. Now just multiply like you did before. It's easy. Division is multiplying by the reciprocal. For instance, 7/8 divided by 1/2 is the same as 7/8 times 7/8 times 2/1. Okay, so we'll multiply, but we'll cancel first. I see the 2 and the 8 are both divisible by 2. Now I've canceled, and I don't see anybody else that can cancel, so I'll just multiply, and I have an answer, 7/4.
Excellent.
Now this multiplication stuff is going to come into play when you need to check an answer that you got when you solved an equation. For instance, we have a situation here where Jim solved the equation 3x plus 12 equals 5, and he got the answer -7/3, and he wants to see if it's right. So let's put in -7/3 and see, in fact, if it works. Instead of x, I'll write -7/3. Now that 3, that blue 3, is the same as 3/1, so it's in the top. So it's really 3/1. Now I'll multiply the 2, but before I multiply, I'll cancel. Okay, and what do I end up with? -7/1, which is really -7, isn't it? And -7 plus 12 does equal 5. So in this case, Jim got the answer correct, because the left side equals the right side. Let's look at another example of this. Suppose for the equation 6x minus 5 equals 7, Jim got the answer of 1/2, and he wanted to see if that was right. Well, same thing. We'll kind of erase the x and put in 1/2. Don't forget that 6 is 6/1. And we'll multiply the 2, but cancel first. 6 and 2 both are divisible by 2. So I'm thinking 3 goes there. I really don't have to write the 1. And all of that is going to equal 3. And 3 minus 5, or 3 plus negative 5, equals negative 2. And the left side doesn't equal the right side. So Jim must have made a mistake. We'll have to fix this, okay? We'll have to resolve the problem until, after checking, the left side equals the right side. Okay? Now I want you to dig in and do the homework and practice that.